everyone. This is a review of the 7th grade material, part 2. There are 20 questions in this assessment, and we see the percentages up here. That's the percentage of students in the 8th grade that got this question correct. So 20% is not a good ROI, return on our investment. The retention of this question is lacking. So this is a two-step inequality. I'm going to make this page a little bit. Let's go to 100 maybe. There we go. I like that. So it says graph the solution of z divided by -2 plus 1 is greater than 0. This is an inequality. Two-step inequality, very similar to a one-step inequality. You would do the same thing. There's just one little trick thing in here that we need to be aware of. And then it wants to graph the solution also, which is another skill. So we have something adding, something dividing. Yes, we will be getting rid of things being added and subtracted just like normal. And that gives us z over -2 is greater than -1. Then we are going to multiply by the reciprocal, which is -2. And this is where a lot of students probably made their first mistake. Whenever we multiply both sides of an inequality by a negative, we're going to flip this inequality sign. It was greater than, now it becomes less than. -1 times -2 is +2. So my solution is z is less than 2. The reason behind that, and we can go into this because this is an important concept of why are we flipping? Well, when we move a variable across to the other side, notice it changes from going from greater than to less than. And so we physically moved it across. Well, when we turn a variable from positive to negative, we're actually moving it across. So that multiplying by negative will change the sign of the variable. And instead of, notice that we kept it on the side. So this is just a flipping the inequality is the way of changing the side. So it's very complex. You really have to know inequalities. You have to do that physical moving and seeing it. So this is a high-end concept. We tend to, students, 8th grade students tend to just memorize, keep, flip, switch, or whatever you all do. We just, I don't know, keep working with it. You would see the logic behind it. It's actually very logical on why we would flip the inequality sign. So now let's graph it. So when we graph, I always show where 0 is. I show my solution. It's going to be an open circle because we are not including, it's not equal to, and my solutions are less than 2. So it looks like this. I don't like this graphing part in big ideas, and if we look at the solution, it's very difficult. You notice that my graphs are always above the number line because when it's on the number line, I don't know which way I'm going. You know which way I'm going? It's hard to see that when it's on the graph. So I think this is a much better representation of solutions, graphing solutions, and you'll see me do my solutions above. So at this point, we would pick this little doohickey. We click 2 and drag left, I think, or maybe it would even, I'd probably click 2, and it would automatically snap that graph onto it. So I click that first, then I click at the solution, and it would provide an open circle, and it would go to the left. So that's how big ideas graphing works. A person walks 1/4 of a mile in 1/8 of an hour. The person, by the way, 85%, much better. The person's speed is blank miles per hour. So I have 1/4 miles over 1/8 hours, and I don't have a unit rate. So if I want to get a unit rate, I need that denominator to be 1. I need it to equal 1 hour and miles per hour. So what can I multiply 1/8 to get 1? Well, if I multiply it by 8. Now, I need this to be an equivalency. So I need this value to be equal to 1 because I want to change it. So what would I need to have in the numerator for it to keep it a value of 1? Would be another 8. And then 1/4 times 8 would give me 2 miles. I'm not canceling anything because I'm just multiplying by a value of 1. And I multiplied this by 8, and notice I changed and got an equivalent rate in a unit rate. So it would be, person speed is 2 miles per hour. So the answer here would be 2. It's a good question. I like that question. A lot of concept, good, important, being able to understand how that works. Tell whether the ratio 9 to 9 and 13 to 7 form a proportion. They're saying, is 9/9 equal, that would mean proportional, to 13/7. So a couple things I already know, that it isn't equivalent, but we can just use the most basic cross product. We know when proportional fractions, their cross products should be equivalent. So 19 times 7 should equal 9 times 13. And 19 times 7 gives me 133. And 9 times 13 gives me 117. So those are not equal, so not proportional. So these two ratios, this is a ratio, this is a ratio, is not proportional. The graph shows the density of a substance. Find the density in kilograms per liter. So you notice I'm looking at my units, liters and kilograms. So find the density of kilograms per 1 liter. So I'm going to look at 1 liter. I see 1 liter is right here. I'm going to follow that graph up on the liter, and then I'm going to follow it over on my kilograms, and I see that I get 1.5. So my answer is going to be the density of the substance is 1.5 kilograms per liter. Does it tell me to put it in a decimal or a fraction or a mixed number? So that's fine. 1.5 kilograms per liter. Pretty straight, pretty simple, and we just got to make sure our units are appropriate. That's kind of one of the trickier things. So 80% correct, that's good. 61, so this is not so good. 61, only half of you got it right. A scale drawing of a square has a side length of 6 centimeters. So a square we know is going to have equal sides. So this is 6 centimeters and this is 6 centimeters because it's a square. The drawing has a scale factor of 1 centimeter is equivalent to 6 feet in the scaling object. So find the actual perimeter and area of the square. So I'm going to do this. I'm going to do centimeters over feet, and I'm going to show my scale factor. This is my scale, and I know that I have 1 centimeter is equivalent to 6 feet, and then I'm going to do in my object, and my object is 6 centimeters to what is my scaled to how many feet? How many feet? So I'm just going to do cross product. Cross product, I'm going to cross, and I'm going to cross, and I get x equals 36, right? And hopefully we could see that. We can see 1 times x equals 6 times 6, x equals 36, so 36 feet. So each side of my scaled object is going to be 36 feet by 36 feet. And now it says, what's the perimeter? Well, perimeter equals 4s because it's a square, we know all sides are going to be the same. So 4 times 36 feet, which is going to give us 144. So the perimeter is going to equal 144 feet. So perimeter is going to be 144. And then the area formula for a square is s squared. And we know the side is 36 squared. So the area is going to equal 1,296 feet squared. So that would be my area answer. Okay, so pretty straightforward. We're just scaling an object. This is my scaled version. This is my actual version. This is my scaled in centimeters, and my actual would be feet. So we're just using that info. Let's look at number 6, 89%. Love it. Write a percent as a decimal. So 7%. The decimal is here. Whenever we convert from percent to decimal, I'm going to take that decimal point and I'm going to move it 1, 2 spaces. So I'm going to get 0.07 as a decimal. The other way we could look at this is we could have converted 7% to a fraction, 7 out of 100%, and we know 7 out of 100 is 0.07 in the decimal. So this is decimal, this is fraction, and this is percent. We should absolutely know by 7th grade how to move and convert from one format to another. This was very reassuring that you were able to at least convert the decimal, 100%, to a percent. If we take our decimal, we're going to move our decimal point 1, 2 places, and yes, it equals 28%. So that was really good. Everybody was good with that answer. Number 8. Number 8 says you estimate that there are 64 marbles in a jar. The actual amount is 46 marbles. Find the percentage of error. Round the nearest tenth of a percent if necessary. Only 26 of you. So if this is, I kind of alluded it to percentage of change. It's kind of like percentage of change, which is, one, you have to find the amount of change. And that is going to be from 64 to 46. So my amount of change, or error, my amount of error is going to be 18. And then my percentage of error, or my percentage of change, is going to equal my amount of error, I'm going to continue to say change, over my original amount, or my true value. So that's going to be 18 over my true value, which is 46. And if we turn that into a decimal, 18 divided by 46 gives me 0.3913 equals 0.3913. We're going to change that to a percent by moving the decimal 2 places, and that gives me 39.13% error. And it says round to the nearest tenth, so I will say 39.1% error. Cool? Yeah. So very similar to amount of change. It just wants to know how much is it changing from the error to the true. Find the selling price of a $10 item after a 50% markup. So a markup is going to be the original price plus the markup. So the original price is $10, and then the markup is going to be 50% of 10. Well, that means 50% is half. Half of 10 is $5. So my cost, my new cost, the selling price is going to be 15 bucks. That should take you less than 30 seconds to do. No calculator needed. You deposit $100 in a savings account. The account earns 5% simple interest per year. What is the interest earned after 8 years? So we have this formula, I equals PRT. Interest equals the principal, this is the principal, $100, times the rate, which is 5%. We're going to put it as a decimal value. So that's 0.05. And T is time in years. So 8 times 8. So 100 times 0.05 times 8 is 5 times 8. So the amount of interest is going to be $40. I get $40 after 8 years of interest. So interest earned after 8 years is 40. And then the balance is going to be 1L, Mr. Mac, 1L. The balance is going to equal the principal plus the interest. So the principal was $100 plus the interest, which is 40. So I have a total of $140 after 8 years. Great question. Shows how simple interest is a horrible way to make money. That compounding interest, and then we can talk about the intricacies of compounding on how many times are we compounding. Is it monthly, 12 times? Is it quarterly? Is it annually? Is it daily? Is it continuously? Yeah, lots of fun differences. Don't get me into savings accounts and how a savings account at a bank is ripping you off. Sorry, I divert. Not a great way to earn money, grow your money, exercise your money, savings accounts. But for another day. The probability of an event is 17 out of 50. Describe the likelihood of the event. Well, is it certain? Is it likely? Is it equally likely to happen or not happen? Unlikely or impossible? Well, equally likely would be 25 out of 50. So where do we stand? Where does our event stand? Well, it's not more, so it's not likely. It's not certain. Certain would be 50 out of 50. Likely would be more than 25. Equal to 25 would be equally likely to happen or not happen. 17, right, is pretty good. That's unlikely. And then impossible would be 0 out of 50. So this would be 50 out of 50. This would be somewhere more than 25. This would be 25. This would be less than 25, which is our situation. Impossible would be 0 out of 50. Good. And most of you got that problem right. Using the table to find the relative frequency of spinning a 6, write your answer as a fraction. Well, we got to find the frequency of spinning a 6. So that happens 9 times. That's successful outcomes over the possible outcomes. Well, how many possibilities were there? If we add up 9, 10, 8, 8, 6, and 9, that gives me 50. So the possibilities of rolling a 6 or spinning a 6 is going to be 9 out of 50. And that's the relative frequency. That was really easy. There are 9 yellow marbles and 10 silver marbles in a bag. You randomly choose one of the marbles. What is the probability of choosing a yellow marble? So we call this PY. What is the probability of Y? Again, how many successful? There are 9 yellow marbles out of 19. Okay, and that's it. That's how you do successful outcomes out of possible outcomes. You have 9 out of 19 chances, or 9 out of 19 probability. The table shows the results of rolling a number cube 250 times. How does the experimental probability of rolling an even number compare with the theoretical? So this is good, and I like the fact that they are showing you that the differences between experimental probability and theoretical probability. those aren't always going to be exactly the same. And much like when we flip a coin, it's not heads, tails, heads, tails, heads, tails. Sometimes it'll go heads, 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 tails. But over a long duration, it's going to move closer and closer to that theoretical probability. Rarely does it stay on it it'll fluctuate, it'll move up and down, but it'll always be moving back towards that theoretical. So let's look at even numbers. So even number, we have 2, 4, and 6. So the experimental probability of rolling an even number is going to be 40 plus 44 plus 36. So 40 plus 44 plus 36, those are the successful outcomes over, it was rolled 250 times. So that's going to give me 120 over 250, which simplifies to 0.48, or we have a experimental probability of 48%, a little bit below 50%, because if we look at the theoretical probability, there are 3 even numbers out of 6. So our theoretical is that we were expecting a 50% chance. So the experimental probability of rolling an even number is 48%, which is blank to the theoretical probability. It's close. It's close to the theoretical probability of 50%. This is theoretical. Theoretical. I don't know if this is how you spell theoretical. And this is experimental. And to get the experimental probability closer to the theoretical probability, blank the number of trials. Well, we know that it's going to always be moving towards this, so we need to increase. We need to continue the number of trials. We want to increase, we want to continue to roll those dice, and we will eventually move closer to 50. We may even get higher than 50 at some point. It's going to move constantly to it and away from it, but it'll continue to come back and forth and move eventually closer and closer to 50% over the duration. Really, really cool. Probabilities, super fun. Bell curve, all that stuff, statistical information, very, very fun to dabble in. Find the total number of possible outcomes when you select one color of wallpaper and one color of carpet. 68% of you, this is called the counting principle. And we take the number of options for wallpaper. Wallpaper has 6 possible choices. And carpets, I have 3 choices. And we multiply those and we get 18 different combinations. And it's OR, OY, OP, PR, PY, PP, BR, BY, BP, GR, GY, GP, YR, YY, YP, RR, RY, RP. So each one of these gets 3 different combinations. So if we have 6 that has 3 different, so that's why we do 6 times 3, called the counting principle. Really, really fun, neat way. The possible number of outcomes, different types of combinations of those wallpaper and carpets. Also, really fun to dabble in and to do some work in. Number 16, you roll a 6-sided number cube and flip a coin. What is the probability of rolling a number less than 2 and flipping tails? Write your answer as a fraction in simplest form. So we're going to take the probability of rolling a number less than 2. How many numbers are those? That's the only one. Probability of rolling a 1. And what is the probability of flipping tails? So probability of rolling 1 is 1 out of 6. There's only one number less than 2 out of 6 possible outcomes. And what is the probability of flipping tails? There's only one tail on 2 possible outcomes on a coin. So we get 1/12. That is the probability, 1/12 if you want it as percent, but I think they said as a fraction. So our answer is going to be 1/12. 1 out of 12 you should expect, rolling a dice of 1 and flipping a tail. And very similar to your combination thing. A couple plans to have 5 children. The gender of each child is equally likely. Design a simulation involving 137 trials that you can use to model the genders of the children. Yes, coins are oftentimes used to show boy versus girl. It's a coin, heads and tail. It's 2 possible outcomes. And so if I want to see what is the probability of, with the 5 kids, is I'm going to toss 5 coins, and I'm going to do that and keep track of those 5 coins, and I'm going to do it 137 times. So that's how I would design a simulation. I would take 5 coins, roll them or flip them, and then look and see and keep track. Okay, what did I get? Did I get how many boys, how many girls? And I would keep track of those sets of 5. Yeah, really good, neat experiment. And you do that in science quite a bit. And then you can roll dice. You have, it's not Mandelbrot. I forget the box that you have for genes and hereditary and dominant genes that you do. I forget what that is called, but I'm sure you know what I'm talking about. Number 18, you want to estimate the number of students in your school who support extra funding for the science club. You survey every second student who enters the school. Determine whether the sample is biased or unbiased. That would be unbiased, because if it's every student, or if it's the students coming into the school, there's no biasy there. Every student is going to, you're going to have 9th graders to 12th graders. You're going to have science kids. You're going to have art kids, PE kids, football kids. You don't have there's no bias there. It is very unbiased. If you surveyed every kid that walked into the science room, that's going to be biased. Okay, because those students are walking into the science room, they have a bias towards liking science or taking science, opposed to a student that doesn't like science isn't going to be walking into science and probably would answer the survey differently. So this is an unbiased survey. Also very important is statistics, is biases, how charts and models are help you convey your information. And maybe you want people to see information in a way, and there are charts that are very biased. So good ethical aspect of that one. Number 19, you ask 120 randomly chosen students to name their favorite ice cream flavor. And this is the chart here. So if you add up these numbers, that's 120. And of those 120, 39 like vanilla, 35 like chocolate, 27 like strawberry, 19 like chocolate chip. So estimate the number of students in the school whose favorite ice cream flavor is chocolate chip. So of the 120, 19 liked it out of 120. So what we can do is we can show a proportion. This is our survey. This one is our survey. And then this is the overall school. There are 1,800 students. So this is total. This is probability. This is 19, and this is the probability of the whole student body. So we can find out by doing that. We can do 120 times x equals 19 times 1800. Let's divide by 120, divide by 120. We get x equals, we can cancel that 0. What goes into 12 and 18? 3. 3 goes into 12 4 times. 3 goes into 180 60 times. 2 goes into 4 2 times. 30. 2 goes into 2 15. And 19 times 15. 19 times 15 gives me 285. So what I would expect 285 students to like chocolate chip. The number of students at the school whose favorite ice cream flavor is chocolate chip is about 285 students. And last one, this is a crazy problem right here. This is very, very bizarre. Not the easiest one. So it says the dot plots show two data sets. So we've got data sets. There were 3 40s, there were 4 50s, there were 2, 4, 6 60s, etc. It says express the difference in the measures of center of data set A and data set B as multiple of the measure of variation. Write your answer as a decimal or whole number. So and then it comes down here and it says the difference in the means. So they told us the measure of central tendency, which is means, of the data set A and B set is blank times the MAD. So MAD is mean absolute deviation. So first let's find the mean. So looking at this, you don't have to add up all these. Right? We see that this is actually very symmetrical. So these are going to counter this, and this is going to counter this because it's same distance away. And so my mean of this data set is going to be 60, and this has the same symmetrical. This data point is going to counter this one because it's the same from the middle, and it's got a symmetrical shape. This is going to counter, this is going to counter. So my mean is going to equal 50. I don't have to spend time finding the mean, and that's really important. So if I could save time in that way. Now, MAD, measure of absolute deviation, is the distance of each point from the mean. So this 40 is going to be 20 away from the mean. And this one's going to be 20, and this one's going to be 20. So my MAD value is going to be, well, that's 20 and 20 and 20. So I have 20 times 3. And this point's going to be 10 away. And how many of these are 10 away from the middle? That's 10. And there are 4 points. Okay, you see what I'm doing? And this is right on it. So that distance is 0. This distance is going to be 10 above it. And it's the absolute value, right? I said the absolute value distance. So the distance is 10, and there are 4 of those. So we have another 4 that are 10 away, and these 3 are going to be 20 away. So that is going to equal 60 plus 40 plus 60 plus 40 is 200, and then we divide it by the number of data points, and there are 20 data points. So the MAD value is going to be 10. And then we're going to do that for this one. So this point is this MAD value. So this is, right, this is my mean. So this is 30 away. There's one of them that is 30. This is going to be 20. There's one that is 20 away. And 1, 2, 3, 4, 5, 6. These are 10 away. So plus 10 times 6. This is right on it. So those all produce 0 values. These are also going to be 10 away. So we have another set of 6 that are 10 away. This is going to be 20 away, and this one's going to be 30. So if I add all those up, that's 30 plus 20 plus 60. So that's 110, that's 110. So that's going to be 220 is all of my distances. And there are 22 data points. So 220 divided by 22 is also 10. So the difference in means of the data. So I have a mean of 60 and a mean of 50. So the difference is going to be 10. That's my difference. My difference is 10 is blank times the MAD. Well, the MAD for both of these was going to be 10. So what is, right? How many times is this difference to this MAD value? Well, it's times 1. 1 times the MAD, because 10 times what would give me 10 times 1. So I don't know how somebody guessed 2%. To me, that's absolutely crazy that one of you knew how to do this. Mr. Mack did not know how to do it. He had to go on to Khan Academy and listen to Sal. But just one little video was great, and it made sense, and I understood it, and I applied that, and I was able to get it. So yeah, that took a little bit more time, but these are measures of tendencies. These are statistical stuff. So this assessment really worked a lot on probabilities, statistics, and well, hopefully you had fun with it, and hopefully you are working towards retaining this information for a longer time. So we want you to be able to not only know it in 7th grade, we need you to know it in 8th grade, and we need you to know it and retain it for high school. Thanks for your time. Good luck.